Hey kiddos, welcome back. We're winding down on our thermodynamics unit. Hopefully you found this a little easier to wrap your minds around than the acid-base unit. I know that theory was pretty difficult for that unit. So let's go on and do another AP question. This one would come from part A of your free response because it requires a calculator. Now, I think the most difficult aspect of this question is paying very close attention to which enthalpy is being referenced. Okay? So I have a 2-gram sample, so that's important information, of phenol. They gave us that. It's burned completely, and 64.98 kilojoules of heat are released. So that means that the delta H for this reaction is 64.98 kilojoules, or delta H for my combustion is equal to minus 64.98. There's a couple of ways you could be writing that, but I think that's important to kind of get that down, what information that is. Now, we've got a lot of tables here, and we're going to be filling in, when you see question marks like that, you can guess that you're going to be filling in a gap within that table. Now, this was for, so you could write it this way if you want. We had 64, or really minus 64.98 kilojoules released for every 2.000 gram sample. So I like to write it as a double unit there because it asks us to calculate the molar heat of combustion. You saw this last unit. A lot of you struggled, so we want to make sure we pick it up at this point. Molar heat means per mole as opposed to per gram. So some of you want to go ahead and convert that grams to moles and then do your division. Take kilojoules, divide it by the number of moles present. And that's fine. That's a fine approach. I just tend to do it this way. I've got 64.98 kilojoules per 2.000 gram sample. I want to get rid of grams and go to moles. Mass to moles, use, you've got it, molar mass. And if I divide that out, I get minus 3058 kilojoules per mole. In this case, it was per mole of phenol. All right? So, or for the reaction as written. Now, it asks me to calculate this delta H of formation here. And it's a combustion reaction, so that means that I'm going to start with my delta H of my reaction as a given. And now I'm going to take products minus reactants. So if you want to go ahead and put these values up above here, you can. That's minus 285.85. Sometimes that helps people, keeps them from getting them all mixed up. That's minus 395.5. That's 0, and that's my unknown. So I have 6 CO2. They're each 395.5 kilojoules per mole times 6 moles. So I now have kilojoules. Plus 3 moles times minus 285.85 kilojoules per mole. So minus 1 times X plus 0, so we don't have to worry about that. If you do your algebra, I did this a bunch of times, and I'm getting minus 173. But I looked on the website, and I think they have minus 161. So I'm not sure. I'm just going to run with minus 173, and if you find my algebra error, I am hoping you will alert me to that as soon as possible. All right? Now, I'll tell you what the biggest mistake on part C is. If you would label what this is, it might help you. This is delta H naught of formation of my phenol, C6H5OH. Okay? Now, it's going to be your tendency, and it's on a second page, so I'm going to go ahead and address it now. You think that this was the last thing you answered, therefore that's the number that should go into the next part. not true. We've got to read it very, very carefully. So let's take a look at the next part. Notice it says, what is delta G for the combustion? Not for the formation, for the combustion. And I didn't quite leave myself enough room, but so let me bring this down here. I've got delta G naught is delta H naught minus T delta S naught. Don't grab the delta H of formation. We want the delta H of combustion. We want the answer from A in here. Now, I need delta G, but it doesn't give me delta S. Well, I am given absolute, positional, whatever you call them, entropy values. And so I can use my sum of formula to calculate that delta S of combustion, just like I did for my delta H, my products minus my reactants. And so it's 6. You see these, you've got the table in front of you, that's 213.6. 3 waters is 69.91 minus my reactants, which is 1 times 144 for the phenol, plus 7 times 205 for the oxygen. Okay, I got those right out of the table. Those were given to me. Remember, when you're doing your homework, you're going to find these in an appendix. But in the context of an AP question, they're given either in the sentence or in a table. So now I calculate that, and I have to put that value in there. That would certainly be worth a point or so. 87.7. It didn't ask me for units, but the 2 units that I have seen most common are the rate constant and delta S, and that was joules per Kelvin, okay, is what I had. And so I have to convert this to kilojoules. So let me erase that. I grabbed the number from below. I have to, since I've got my delta H in kilojoules, I need my delta S. Okay, so this answer was 87 minus 87.7 joules per Kelvin. Didn't ask for the units, but go ahead and give them. And I have to put that in kilojoules. And my temperature was 298. So if I plug all that in, I get a delta G naught equal to minus 3032 kilojoules. Okay, so be careful, common mistakes. You've got to get that into kilojoules. And the other common thing I've seen on this question is grabbing the wrong delta H value from the prior questions. Okay, now let's do D. Again, do you remember the good old tools of the trade? You know, this is exactly why I did it this way. Because here we go, here we have a reaction, and lo and behold, we have to use within thermodynamics, stoichiometry, and Pevnert. Okay, so we're given a volume and a temperature, and we are asked for a pressure. So I hope that pushes your mind into the direction of Pevnert. And so I had 2 grams. If you've already calculated your moles from the previous problem, that's a bonus because you already have those moles. I did that as a double unit, so I had to do this separate. So 1 mole per 94.12 grams. Now it's said to assume that there's no oxygen. That means all of my gaseous substances are the products, and I had 9 moles of products. I had the 6 CO2 and the 3 waters formed for every 1 mole of C6H5OH. I don't have to do these separately. I can go ahead and add those together, and that gives me a total of 0.1912 moles of gas present. So stoichiometry is not going to leave you the whole year. You can expect to be doing stoichiometry. It's a very valuable technique. Now I'm going to hop into Pevnert. Pressure is moles, 1912. Now, this question I noticed didn't give me a particular unit for pressure. I went ahead and grabbed 0.0821, but I would hope they would be accepting of all reasonable units, which would be, frankly, torr and pascals, kilopascals for this. Okay, over our 10 liters, you have to have liters, remember. You have to have Kelvin. And this gives us a pressure in atmospheres, 0.601 atmospheres. And I would assume that if you'd used 8.314 here, they would have accepted kilopascals because the question did not specify units. Wow, we were covering a lot, but the good news is we've reviewed a little bit for your test, because if you haven't started reviewing yet for that AP test, man, it's going to get harder and harder, and cramming chemistry has made many a tough men and women cry, and we don't want crying chemistry students. So start practicing now, start reviewing now, and you're going to breeze into that test day. All right, one more question. Till then, this is signing off.